Hello, good morning. Uh, Computer network and security. This is the one compulsory subject for your semester 2 of your curriculum of the Pune University. And here the unit number 1, that is introduction to the computer network. So we have to study this in this unit. The general idea of the computer network is given. Uh, this is the presented by me. Here, the after studying this unit, student will be able to design, implement, and analyze simple computer network. That is, this is the course outcome 1, and which matches the program outcomes that are 1, 2, 3, and PSO2, where PSO2 is the program specific outcome, and this matches to Bloom's taxonomy level 4, 5, and 6. Content under this lecture, we have to study the network models. Under this, we have to study the layered task, then the OSI model, then layers in the OSI model, then TCP/IP protocol suite, then addressing. Different addressings are used in the computer network. So all these things we have to study under this lecture. So one by one we will see this. So here layered model, we will see the example of the sending the letter, how the letter is sent with the post office. We will see that first. So here the sender is there, this one is the receiver. This whatever the data, or we can say this letter, it flows through this different layers, starting from the higher layer, then the middle layer, then the lower layer, and again at the receiver side, it is from the lower layer, middle layer, and the higher layer. So it is a layered task, layered structure. So here the letter is written, put it into the envelope, and dropped into the mailbox. The letter is carried from mailbox to post office. Then the letter is delivered to the carrier by post office. Then it is this parcel is carried from the source to destination by the different media. The letter is delivered from the carrier to the post office. It is at the receiving side. Then the letter is carried from the post office to mailbox. It is again. Then the letter is picked up, removed from the envelope. It is removed from the envelope, and it is read by the user. Okay, so this is the layered model, how the layered model works. So each layer is having some defined function. It will perform that, and it will give the services to layer below it. Okay, so next one we have to study the OSI model. Now, what is OSI model? We will see it in detail. You can see it is having the different layers. There are 7 layers. The first one is the physical layer, then data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So here, this ISO, the International Standard Organization, developed this OSI model. OSI is the Open System Interconnection Model. So the different functions performed by this OSI model. The open system interconnection, it is a reference model. We can see it is theoretical model, and the practical one is the TCP/IP. Now it allows the network components from different computers to interact. This means the different components can interact from the different systems. It provides peer-to-peer logical services with the layered physical implementation. Peer-to-peer logical services means the process on each machine that communicate at the given layer are called the peer-to-peer processes. means one process is running the at given layer in the sending machine, same at the receiving side. So the layer from the sender and layer from the receiver can communicate with each other. That is the process to process communication. So it provides standard for communication between system. It provides the defined standard. Then define point of interconnection for exchange of information between system, and each layer perform well-defined function. Okay, so it gives the point of exchange of the information, as well as each layer it is having some defined function. Okay, so these are these detail of the OSI model. Now you can see over here, these are these first three models. Then in between the transport layer, and again this first three layers in between this transport layer, and then again these three layers. So these are called the media layer, and these are called the host layer. These bottom three layers are the called the media layer. It is a system related, and these upper three layers we can say it is a user friendly. So this media layer means the we can say it is related to the network, and this is this above three layers, top three layers are the user friendly layers, we can say. And this middle layer, transport layer, which separates these layers. So one by one we will see this physical layer. It is the data flows in the form of the bits. It is a media, signal, and binary transmission of data. Okay, then at the data link layer, data flows in the form of the frames. Then it is responsible for this MAC, media access control, as well as the logical link control, and nothing but the physical addressing. Then the network layer, the data flows in the form of the packets, and which determines the path and means that is routing, and the IP addresses are there we have to study. Then transport layer, which is responsible for end-to-end connections, which creates the end-to-end connections, and how the reliable data transfer. So here it is in the form of the segments. Okay, then the session layer, host, inter-host communication. Then presentation layer, data representation and encryption, and the application layer, network process to application. Means application layer, the user can use the applications. Then interaction between layers in the OSI model. How the interaction between these layers takes place. Here we have to study layer and interface. We can see here how the sender and receiver, or we can say this is the device A, this is device B. Data flows from this intermediate nodes to this destination. And we can see over here, the again 7 layers are shown over here. As I told you, this is this first 3 layers are the network layer, network defined layer, and these 4 layers are the user friendly layers. And here the network is organized in series of layers, each one built upon below it. Because of the layer, it reduces the design complexity. In layered protocol, a layer is a service provider and may consist several service functions. Protocols are the rules that govern the network communication. So here, an entity is a specialized model of the layer, and peers, the entities comparing the corresponding layer on the different machine, are called peers. For example, work group means there is the no hierarchy, all are equal, no administrator responsible for the network, like that. It is a peer to peer, or we can say peer. So the actual data flows from upper layer to the layer below it, and then flows from physical medium to the destination. And then the interface between each layer of the adjacent layer, is called the interface. This is called the interface, and these are the peer-to-peer protocol. And it is defined which primitive operations are and services the lower layer offer to the upper layer. The set of layers and protocol is called as the architecture. So if they ask here the what is draw the architecture of this OSI model, then you should be able to draw this architecture. Means you have to draw this diagram and you have to explain this. Okay, so this is the interaction between the layers of the OSI model. And exchange using the OSI model, how the data flows. You can see in this figure. Again, this one is the sender, this one is the receiver. Data flows from this upper layer to the lower layer, and at the receiving side, it is from the bottom layer to the top layer. So some informations get added into this data. That is nothing but the an exchange of the information, means encapsulation with the header and possibly of the trailer. Now, one by one, we will see this layer in detail. First, we will see the physical layer. You can see this figure. This is for the physical layer. So it takes the data from the data link layer and transmit through the transmission media, and it is again given to the data link layer as the destination, or we can say receiver. The physical layer is responsible for movement of individual bits from one hop to the next one. Here, mechanical and electrical specifications are defined, as well as the procedures and functions. Then we have to see the physical layer duties. First one, the physical characteristics of the interfaces and media. Means it defines the physical characteristics and interfaces of the media. Then representation of bit, how these bits are represented. After that, data rate, how fast the movement of bits are to be done. Then synchronization of bits. After that, line configuration, means here the data, how the line configuration is done, means that is point to point communication or the multi-point communication are there. That is to be defined. Then physical topology, how the devices are laid down. That is the physical topology, maybe star topology, mesh topology, ring topology, hybrid topology. Okay, so like that, which one is the perfect for the application. Then transmission mode. These are the duties of the physical layer. The next layer is the data link layer, and we will see this. This is the diagram for the data link layer, which takes the data from the network layer and give to the physical layer. Means it provides the services to the we can say for the network layer as well as the physical layer. Then at the receiving side from the physical layer, and it gives to the network layer. So here the data link layer is responsible for moving of the frames from one hop to the next hop. Here data at the physical layer, data is in the form of the bits, and that bits is converted into some fixed format, and that is known as the frame. Okay, so the data flows in the form of the frames here, and then transform the physical layer to the reliable error-free link. It transforms the physical layer to the reliable error-free link. Then we will see the data link layers duties. The first one is the framing. Just I told that at the physical layer, data flows in the form of the bits, and that bit is converted into some fixed format, and that is known as the frame. Then it is responsible for the physical addressing. Physical address, which is the assigned to the computer at the time of the manufacturing, and it is present on the network interface card. Okay. Then next duty is the flow control. Why this flow control is required? Because if the sender is processing, or sender is sending the data, and receiver is receiving, if the receiver is not processing the data as fast as the sender is sending, then there will be the congestion, or the data will not get processed processed easily, or we can say properly. Then there should be the some flow control mechanism. So this flow control is performed by this data link layer. Then error control. If there is some error, means some frames are not received at the receiving side, okay, and that must be corrected, or that must be retransmitted. That is nothing but the error control. Means some frames are lost, and that must be that are to be retransmitted. That is the error control. Then access control. So there is a medium, or we can say channel, and the which stations is allowed to transmit in data. So that is called the access control. Then hope to hope delivery. What is this hope to hope delivery? You can see this diagram. The physical layer and data link layer are connected over here like this. Data flows from data link layer through the physical layer. So here, this is the nothing but the hope to hope delivery. We can say this is the end system, this is the end system, this one is the end system, and data transmitted from this sender to this next node. That is the, we can say, intermediate system, and this is known as the hope to hope delivery. One data flows from one node to other one. That is called one hop distance, and that is hope to hope delivery. Then next layer we have to study, which is the network layer. You can see here the network layer. This is the data flows from the transport layer and given to the data link layer, and it is again from at the receiving side from the data link layer to the transport layer. So the network layer is responsible for delivery of the packets from the source host to the destination host. At this network layer, just we have seen the at the network layer, data flows in the form of the packets. The frames are converted into the fixed format, that is known as the packet, and these packets are transmitted from source to destination. So this network is responsible for this packet delivery. Then we will see the network layer duties. You can see this diagram. This network layer is responsible for logical addressing and routing. So this logical address, we called it is the IP address, or we called it is the network address. Okay, so it is a unique and universal, and by this the computers communicate from uh, one location to other location, or we can say on the internet. So here end systems are there. This is the end system, this one is end system, this one is end system, and this is connected by this link. Intermediate system, again link, intermediate system, link, and at the end system. So here source to destination, source to destination. This is the packets sent from the source to destination, or we can say it is a source to destination delivery, and this is the responsible for that. Routing is nothing but the finding the path or the location where the data is to be sent. Then next one is the transport layer. You can see in this figure, data is taken from the session layer and given to the network layer. Again from the network layer to the session layer. Then the transport layer is responsible for delivery of the message from one process to another process. So as we know, the different computers are there, and to communicate these computers, only the physical addressing and logical addressing is not sufficient, and as so many processes are running on the computer, and to communicate or to reach to the that process, there should be need of the some address, and that is called the port address, or we can say it is a process to process delivery, and this transport layer is responsible for that delivery. Then we will see this transport layer duties. It is a service point addressing, or we can say the port address. Nothing but the just I told that the so many processes are running on the computer, and to reach to the that process, there should be need of the service point access, and that is known as the port address, or we can say process address. Then segmentation and reassembly. Data is segmented and then it is assembled. Then connection control. The connection is established and then it is controlled. Then flow control and error control. Just I told in the one of the previous slide, flow control, that is when the sender sending the fast and receiver is not performing or not processing as fast as the sender, so there will be the congestion, and to avoid, there should be the mechanism of the flow control. Means sender will stop to sending the data or will restrict it. Then error control, some data or we can say packets are missing, and that is again retransmitted. That is flow control. Now, next one, same one, reliable process to process delivery of the messages. You can see this. This one is the sender. This one is the receiver. Or this computer communicate with this one. And as we know, so many processes are running on this computer at the same time. So here, this is connected by an internet, or we can say computer communicate on the other computer by the internet, through the internet, and this at the network layer, host to host delivery is there. But as so many processes are running, to make the process to process communication, if the process to process communication is there, then and then the reliable reliable communication is happen. Otherwise, or not complete communication is happen, and to make the process to process delivery. This transport layer is the responsible for that. Then session layer. We will see this diagram, session layer, which takes the data from the presentation layer and gives to the transport layer, and at the receiving side takes from the transport layer and given to the presentation layer. So here this session layer is responsible for dialog control and synchronization. Then presentation layer. You can see this is the diagram of the presentation layer, block diagram of the presentation layer. Then we can see block of the presentation layer takes the data from the application layer and gives to the session layer, and at the receiving side from session layer to the application layer. So here the presentation layer is responsible for translation, compression, and encryption. Okay, data is translated, compressed, and encryption for some security purpose. Then the application layer. You can see this diagram for the application layer. It is a user, human, or the program. Then gives the services to this presentation layer. Then from presentation layer to the application layer. So here application layer is responsible for providing the services to the user. This application layer is responsible for application layer is responsible for providing services to the user. It provides the services to the user, like the sending the mail or file transfer or the terminal login, like that. Application layer services, we can see over here the network virtual terminal. Just I told that is the remote login, means the remote machine can be logged from your location. Then mail services, you can mail, we can send the mail or receive the mail. Then file transfer, access, and management. The protocol used here, the FTP, file transfer protocol, and by that you can transfer the file, access the file, and the overall management of that. Then directory services, it is also responsible for the directory services. Then summary of layer. You can see this is the diagram of this OSI model. 7 layers are there. As I told, the OSI model, which is the reference model, ISO, International Standard Organization, developed this OSI model, and this OSI model is allows the network components from different computers to interact, and it performs like provide peer-to-peer logical services with physical layer physical implementation. Then provide standard for communication between system. Then define the point of interconnection for exchange of information between the system, and each layer is having some well-defined function. So these are the this is about this OSI model. And here summary of each layer is given. You can see this is the physical layer. At this physical layer, to transmit the bits over the medium, to provide the mechanical and electrical specification. This is the work, or we can say duties of the physical layer. Next one is the data link layer. Here to organize bits into frames, then means it is responsible for that the data is converted into the frames to provide hope to hope delivery. As we have seen, the hope to hope means nothing but the node to node. Then the network layer to move the packets from source to destination. This network layer is responsible for, or we can say data flows at this in the form of the packets from source to destination, and to provide the internetworking. As I told you, the logical addressing and routing is the functions of the network layer. Logical addressing, nothing but the IP address. IP address unique and universal, and it is used to connect the computers over the internet, and provide the internet working. That is provide the internet working, and as well as routing. Next one is the transport layer to provide reliable process to process message delivery and error recovery. It is responsible for the process to process delivery, and here we will require the port address. Then session layer to establish, manage, and terminate the session. This session layer is responsible establishing, managing, and termination of the session. Means it is established, or we can say establish the connection, manage it, and terminate that, or we can say session. Then presentation layer to translate, encrypt, and compress the data. To translate, it is responsible for translation, encryption, and data compression. And at the application layer to allow access to the network resources. So at here, the user is using the different services. Just I told in the previous slide, mail services, file transfer, terminal login. Okay, everything whatever we are doing on the computer that are done by this application layer. So in this lecture, we have seen these details of this OSI model. There are 7 layers of this OSI model: physical layer, data link layer, network layer, transport layer, session, presentation, and application layer. Okay, this is the reference model used in the computer networking. Okay, so thank you. We have to study the transmission media. Transmission media, how the signal transmits from one place to other place. So what kind of media it takes? Yeah, through it transmit. So here, first one is the guided media, or we can say wired media. The signal is guided, and another one is the unguided media, that is wireless media. So here, transmission medium and physical layer. So we will study this. You can see this in this diagram. Sender is there, then physical layer. After that, the transmission medium is there. It may be the cable, or it may be the ear, or we can say that it is the wireless. And again, it is the physical layer, the 7 layers of the OSI model. Physical layer at the sender side, physical layer at the receiver side, and then it is come to the receiver. So sender and receiver there. In between them is the transmission medium is there, and that we have to study in this lecture. So classes of transmission media. The transmission media is classes in the two class. First one is the guided media, or it is called wired media, and another one is the unguided, that is the wireless. Again, this guided media is classified as, or the types. First one is the twisted pair cable, then the coaxial cable, then fiber optic cable. So twisted pair cable, one by one we have to study this. Twisted pair cable, again it is a UTP and STP, unshielded twisted pair and shielded twisted pair, that we have to study. Then this coaxial cable, then fiber optic cable. Then under the unguided media, that is wireless, the free space is used to transmit the signal. So twisted pair cable, you can see in this figure, the conductor is inside this cable, and this cable is twisted. On upper side, the insulator is there. So this is the twisted pair. Next one, we have to study this UTP and STP cables. You can see in this first figure, that is the untwisted pair cable. You can see in this figure, in between this is the conductor, then after that the insulator is there, and again on the upper side it is a plastic cover is there. Okay, the next one is the STP, shielded twisted pair cable. Again, the main conductor, inside the conductor is there. After that, the insulation is there, and then some metal shield is used for the shielding purpose, that prevents the introduction of the noise. So these are the UTP and STP cable. Then categories of the UTP cable. We have to study these different categories of the UTP cable, and you can see in this figure, the first column, it is the category, then the specification is there. After that, the data rate is there, that is in Mbps, and then it is its use, where this cable is used. So category 1 is unshielded twisted pair used in the telephone, whose data rate is less than 0.1 Mbps and used in telephone. Unshielded twisted pair, originally used in the telephone lines, and data rate is 2, so that is the T1 lines. Then the category 3, improved CAT2 used in LANs. Nowadays it is used in LANs. Data rate is 10 Mbps, the use in this LANs. Category 4, improved CAT3 used in token ring networks. The data rate is 20, used in LANs. Similar way, category 5, cable wire is normally 24 gauge with the jacket and outside seat. 100 Mbps the data rate is there and used in the LANs. Then 5E extension of the category 5, data rate is the 125 and used in LANs, which minimizes the crosstalk and electromagnetic interference. Then category 6, it is the new category, match components coming from the manufacturer. The cable must be tested at the 200 Mbps data rates used in LANs. And category 7, sometimes called as the STTP, shielded screen twisted pair, 600 Mbps data rate used in LANs. So these are the categories of the UTP cables. Depending on the applications, these UTP cables are used. Mostly it is used in the LANs and telephones. Then UTP connectors, the different UTP connectors we have to study. This first one is the RJ45. RJ stands for the registered jack, and you can see in this figure the RJ female connector, and this one is the RJ male connector. After that, UTP performance, how it gives the performance. On the x-axis, the frequency is there, and on the y-axis, the attenuation is there. and the different gauges are used. For 18 gauge, the characteristics is like this: 22 gauge and 24, 26 gauge. This is the UTP cable performance. Frequency increases, the attenuation is also goes on increasing. Then parallel flat wire cable. As the electromagnetic interference can create the noise, the noise over parallel wires result in an uneven load and damage the signal. So you can see in this figure, shows in the how this interference occurs on the parallel wire. This is the sender, this one is the receiver, this is one cable, this is the another cable. This On this side noise effect is of 12 units, and on this side it is of the 16 units. Total noise effect is equal to 16 minus 12, that is 4. Is the noise effect. This one is the noise source, so that the noise occurs there. So what happened in the parallel flat wire? The total noise effect is of the 4. So what happened on the twisted pair? Noise effect on the twisted pair that we have to study. The cumulative effect of the noise is equal on the both sides, and twisting does not always eliminate the noise, but does significantly reduces it. We can see with this figure. See this cable, this one is the sender, this one is the receiver. The cables are twisted like this. On this cable, the noise is shown with this red arrow, and on this it is by this green arrow. And you can see the total noise effect on this wire is 14, on this also 14. So 14 minus 14 is equal to 0. That is, cumulative effect on noise is equal on both sides. The cumulative effect is equal on both sides, and twisting is not always eliminate the noise, but does it significantly, means it not completely reduces the noise, but it reduces it. Okay. Then next invention is the coaxial cable. So the disadvantages of the these UTP and STP is eliminated here by this coaxial cable. Carries the signal of the higher frequency ranges that those in the twisted pair. As we have seen in the performance of the twisted pair cable, as the frequency increases, the attenuation increases. So the remedy for that is the coaxial cable, or the next invention is the coaxial cable. Carries the signal of the higher frequency ranges that those in the twisted pair cable. You can see this figure for the coaxial cable. Inside that, this is the inner conductor, the main conductor is there. Then outer conductor is there. In between that, there is the insulator. On this side, the insulator is there. On this side, the insulator is there. And above that, the plastic cover is there. So this is the coaxial cable. So categories of the coaxial cable. Again, you can see this is the this first column is the category, then the impedance, and then its use. This is the RG59, that is the radio guide 59, RG58, RG11. So this RG59, the impedance is 75 ohm, and it is used in cable TV. RG58, 50 ohm impedance, that is used is the thin Ethernet. Then RG11, 50 ohm impedance, and that is the thick Ethernet. So these are the categories of the coaxial cable. Then some connectors used in these wires called the BNC connector. The full form of the BNC is that Bionel Consulman connector, as it is used in our laboratory. The CRO cable, or that CRO cable that is connected to the CRO, that connector is called as the BNC connector. you can see this picture of the BNC connector. This is the BNC connector. This one is the cable. This is the BNC, the T type, and this is the 50 watt BNC terminator is there, and this one is the ground wire. So these are the connectors used in this cables, coaxial cable. So coaxial cable performance you can see in this figure. On this x-axis, the frequency is there. On the y-axis, the attenuation is there. And somewhat the performance is increased by this cable as compared to the twisted pair cable. Then next invention is the optical fiber. As the performance of the coaxial cable is not up to the marks, means if the frequency increases, the signal goes on decreasing, the attenuation takes place. Hence, the next invention is the optical fiber cable, and optical fiber is made up of the glass or plastic. It transmits the signal in the form of the light. The nature of the light, you can see as the speed of light is 300,000 kilometers per second in the vacuum, and it depends on the density of the medium through which it is traveling. So, so the signal transmit at the speed of the light. So it transmit rate is very fast, and this is the main advantage of the using the optical fiber cable. Other properties of the light are refraction, critical angle, reflection are there. So bending of the light, you can see this is the when this incident angle I is less than the critical angle, refraction takes place. This is the more dense area, this is the less dense area. Then when this angle is equal to the critical angle, the refraction takes place, more dense area, and this is less dense area. And the critical angle, the size greater than the critical angle, the reflection takes place. This is more dense area, and this is less dense area. And this property is used in this optical fiber cable to transmit the light. So here, optical fiber, you can see this optical fiber cables structure. Sender is there, then the receiver is there, then this middle one is the core, and above that on the both side cladding is there. So this light signal transmit, it is reflected back again, and again the reflection takes place, and like this it is transmitted up to the receiver. Then propagation modes. We have to study the propagation modes of this signal. These propagation modes are two types, multi-mode and the single mode. The multi-mode is again classified as the step index and graded index, we can say fiber. And this one is the single mode. So these modes, you can see in this figure, all these three categories are shown over here. Multi-mode step index, multi-mode graded index, and this is the single mode. So this one is the source. The how these signals you can see in this. This is the multi-mode, and the step index. The signal transmits in the steps. Okay, and this one is the destination. And then this one is the second one is the multi-mode graded index, multi-mode graded index. And the last one is the single mode. Then we have to study the fiber types. So here, different fiber types are given. First one is the type, then core diameter, then cladding diameter, and the mode of this operation. So 50/125, the 50 micrometer core is there, then 125 cladding, then it is a multi-mode graded index. Like this, it is 62.5/125, 62.5 core, 125 cladding, multi-mode graded index. So like this, 100/125, 7/125. These are the core diameter and cladding diameter, or we can say size. And these are the multi-mode graded index. And the last one is the single mode. These are the fiber types. Then you can see the fiber construction, series cable, fiber cable, how the its construction is there. This one is the glass or a plastic core. Then this one is the cladding material, cladding. After that is the cladding. Then you can see this is the plastic buffer. Then some protection is required. That is the to increase the strength of that. This duo bond cable material is used for increasing the strength of that. And this one is the outer jacket. This is the structure of the fiber optic cable. Fiber optic cable connectors, the different connectors we have to study. The first one is the SC, subscriber channel connector, used for the cable TV. It uses push-pull locking system. Second is the straight tip connector, used for connecting cable to networking device. It uses the reliable bayonet locking. And then the third type is the MTRJ, is the same size as the RJ45. You can see in this diagram these three types of connector. The first one is the SC connector, that is subscriber channel. Second one is the ST connector, that is the straight tip connector. And then MTRJ connector, like the RJ45. So these connectors are used in the for connecting the fiber cables. Then performance of this optical fiber cable, you can see this as wavelength increases. Before that it is somewhat constant, but as it is increases, the loss is somewhat increases at this point. But here it is decreasing. Okay, so this is the performance of the fiber optic cable. Then advantages and disadvantages of the optical fiber. Advantages, we will see the advantages first. It is having the higher bandwidth. Higher bandwidth signal can be transmitted. Less signal attenuation, as we have seen in the graph. The signal attenuation is less as compared to the coaxial cable and the twisted pair cable. Then immunity to the electromagnetic interference. The electromagnetic interference occurs very less. Then resistance to corrosive material. It is having some resistance for the corrosive material, means it is corrosive proof. Then lightweight, definitely it is very lightweight. Then greater immunity to the tapping. For the tapping, it is having the greater immunity. Then disadvantages, it is also having some disadvantages, and that we have to study. The first disadvantage, that is the installation and maintenance. It is definitely high. Installation cost and installation is very and maintenance is very high. Unidirectional light propagation, light propagate in unidirection only, and definitely cost is initial cost is more of this optical fiber cable. Then next one, we have to study the wireless transmission media, and for that first we should know the electromagnetic spectrum for the wireless. That electromagnetic spectrum, uh, electromagnetic spectrum is nothing but the range of that frequencies over which this signal transmits. So the starting from this 3 kilohertz, the up to the 300 gigahertz, it is the radio and microwave. Radio wave and microwaves are there. Then in between the 300 to 400 terahertz, the infrared range is given. In this range, the infrared devices operates, and above this 400 to 900 terahertz, the light wave is given. This is the range of the light wave, or which this devices operates. Then propagation method. How the signal propagate through this, or we can say how the signal propagate. Okay, so how this electromagnetic signal propagate. So you can see here, the first one is the ground wave propagation, second is the sky wave propagation, and third one is the line of sight propagation. So here we have seen, we know that is the ground wave propagation, then sky wave propagation, and line of sight propagation. So ground wave propagation around the earth, the which is the below 2 megahertz, you can see over here, the signal transmission takes place. This one is the earth, and this is the surface of the earth, and this one is the ionosphere. Okay, so it is the around the earth, means the through the surface of the earth the signal transmit, that is known as the ground wave propagation, and it happens below the 2 megahertz frequency signal. Then next one is the sky wave propagation. The sky wave propagation, it is in between the 2 to 30 megahertz frequency range. And what happened in this? This one is the transmitter, this one is the receiver. So from this transmitter, the signal transmit, it reflected back by the ionosphere, and again it is received by this receiving antenna. So this is the sky wave propagation. And then this last one is the line of sight propagation. It happens above the 30 megahertz frequency range, and you can see this is the transmitter and this one is the receiver, and it is the line of sight propagation. So the transmitter and receiver both are in front of each other, and through that the communication takes place, or signal transmission takes place, known as the line of sight propagation. These are the propagation methods of the signal. Then we have to see the different frequency bands. The first column is the band, second one is the range, third one is the propagation, and the last one is the application. So first band is the VLF band, very low frequency band. Its range is from 3 to 30 kilohertz. The propagation method is the ground wave propagation, and its application is the long range radio navigation. Second band is the LF band, low frequency, 30 to 300 kilohertz. This is the ground wave propagation, radio beacons and the navigational locators. Then middle frequency EMF band, 300 kilohertz to 300 megahertz, the skywave propagation used in the AM radio. Then HF band, high frequency, 3 to 30 megahertz skywave propagation. It is used in the CB radio, that is citizen band radio, or C public aircraft communication. Then VHF, very high frequency band, 30 to 300 megahertz, sky and line of sight propagation, and VHF TV FM radio. Then UHF, ultra high frequency, 300 megahertz to 3 gigahertz line of sight propagation is used. UHF TV, cellular phones, paging, satellite, these are the applications. Then SHF, super high frequency, 3 to 30 gigahertz line of sight satellite communication. EHF, extremely high frequency, 30 to 300 gigahertz line of sight used in radar and satellites. So these are the different bands, the range of frequency propagation, and the applications. Now, we are interested in this wireless transmission wave, how these waves are transmitted, or the so wireless transmission. It is categorized in three types. First one is the radio wave, then microwave, and IR or infrared wave. As we know, the radio wave, then microwave, and the infrared waves. These are the types of the wireless transmission. So wireless transmission waves, radio waves are used for multicast communication such as radio and television and paging system. This first one, radio waves, are used in multicast. Multicast means one to many communication. It is a radio and TV and paging system. Then microwave are used in unicast, one-to-one communication such as cellular telephones, satellite network, and wireless LANs. And third one is the infrared. These IR signals can be used for the short range communication in closed area using line of sight propagation. So these are these three types of this wireless transmission: radio wave, microwave, and IR signal. And these are the applications. So these some types of antennas are used in this transmission. You can see this is the first one is the in this picture shown omnidirectional antenna. Then second one is the dish antenna. We can see it at our home, the dish antenna. And then this one is the horn type antenna. This is the waveguide. So these are the some types used here: omnidirectional and unidirectional antenna. What is this one is the omnidirectional on the all the sides. Then these are the unidirectional antenna used in the transmission. Okay. Then infrared IR. So this infrared waves with the frequencies from 300 gigahertz to 400 terahertz for short range communication in closed area using line of sight communication. So here this in this IR transmission, the frequency range is from 300 gigahertz to 400 terahertz used for the short communication in closed area, but it is a line of sight propagation. It is used for the line of sight. The propagation used is the line of sight. Having high frequencies, it cannot penetrate into the walls. Through the wall, it cannot go, or we can say it cannot transmit or penetrate through the walls. IRDA is the infrared data association, one of the standard for standards in the used in the wireless devices. So here the example given, IRDA port for wireless keyboard is originally defined a data rate of 75 kbps for distance up to 8 meter, and the recent standard for the data rate of 4 Mbps. So recent standard for this data rate is used the 4 Mbps. So in this lecture, we have seen the the transmission media. Main is the divided in two types. One is the wired and the wireless transmission. Wired is classified in three categories. That is the twisted pair cable, then coaxial cable, and then the fiber optic cable. We have seen all this construction working and the types of the wires, the uh, different connectors are used to connecting that wires. Then we have seen the wireless type of the wireless transmission. It is of these three type: radio wave transmission, then microwave transmission, and the IR, that is infrared transmission. So this all these transmissions, or we can say the transmission medium, wired and wireless, we have studied in this lecture. Different antennas used here. Then this is the infrared, the range of these frequencies. Then advantages, disadvantages of that. We have seen this example of the wireless keyboard, IRDA port for the wireless keyboard. It is originally defined a data rate of the 75 kbps for a distance up to 8 meter, and recent standard for data rate is the 4 Mbps. This is about the wireless keyboard. Nowadays, this is the very popular used in this communication, or we can say the computer networking. So thank you. Hello friends, I am Professor Ramesh Khinde. I am going to explain the some computer network fault findings. This video, this presentation will analyze common network faults, highlighting troubleshooting strategies and preventive maintenance practices. This presentation is designed to equip IT professional and network administration with the knowledge and tools needed to diagnose and resolve the network issues effectively, ensuring the optimal network performance and uptime. So this video is useful for the fault finding in the computer network, and by that you can restore your equipment in a good condition. The common network faults are cabling and hardware issues. Well, actually, hardware and software issues are there. So the first one is the cabling and hardware issues. Another one is the software configuration problems. Now, under this hardware issues, there may be the loose connection, damaged cables, and faulty hardware components can disturb the network connectivity. So, if there is there any loose connection, or the soldering is not properly done on the kit, so that comes under the hardware issues. Then under software issues, incorrect settings, outdated software is not updated, and the security configuration can lead to the network instability. If your network is not secured properly, then that creates the problem in the network. The in detail, cabling and hardware issues are the I have explained in detail. Cable integrity. First one is the cable integrity. Check for breaks, kinks, or improper crimping. while you are making the cables and it is not properly crimped, then it creates the problem in the connection. Then second one is the connection security. Ensure all cables are securely plugged in. If it is not plugged in properly, then there may be the problem, maybe some security issues arises. Then hardware functionality. Test the switches, routers, and network adapters for proper operation. Okay. Then under this software configuration, software problems are there. For example, the firewall rules, then routing tables, network services, etc. So one by one, we will see this in detail. The first one is the firewall rules. For that, verify that firewall are configured appropriately to allow necessary network traffic. Firewall is nothing but the some traffic controller which is connected in between the network. Nothing but the filter. We can see it is nothing but the filter. So verify that firewalls are configured appropriately to allow necessary network traffic. Then routing tables. Uh, the function of the network layer, that is the which routes the uh, path or find the path, or that will require the table, routing table. And here ensure routing tables are updated and correctly configured to guide the network traffic. If that table is updated or not, so if it is not, that will create the problem. So the routing table should be updated. Then network services. Check for any conflict or issues with essential network services like DNS. DNS is nothing but the domain name system. Then the DHCP, Dynamic Host Configuration Protocol, it is properly um, uh, assigned or not. Or the FTP, File Transfer Protocol, it is properly working or not. Or if it is not properly working, then it may create the problem. Okay. Then network protocols. Next point, the network protocols. The network protocols, we are working with the computer network, and which is having the 7 layers in the OSI model. So different layers are there, that physical layer, then data link layer, network layer, session presentation, application layers are there. So each layer is having its protocol, which are functioning properly. Means the transmitter is transmitting and receiver is receiving according to the protocol. So it may create some protocol errors if it is not properly assigned. So for example, TCP/IP issues. Troubleshoot TCP/IP stack configuration, network address conflict, or incorrect subnet mask. What is meant by this TCP/IP? TCP/IP is the Transmission Control Protocol Internet Protocol. Okay, which is the protocol used to assign the addresses. So here, by troubleshooting the TCP/IP stack or configuration, the network address conflicts are there that can be corrected by using the DHCP, or incorrect subnet mask may be assigned. So that creates the error in the computer network. Then UDP packet. Next one is the UDP packet. So analyze UDP packet loss, delays, or communication error. If the packet is not arriving within the certain time, then the delays are created there, and by that the error may occur in the communication. Then if protocol mismatches happens, that may create the error. So very first you have to verify that device on the network use compatible network protocols. Okay. Then next point we have to consider in the fault finding, that is bandwidth and performance bottlenecks. What is meant by bandwidth? Bandwidth is nothing but the which will give the rate of transmission, or we'll say the transmission rate, bits per second, or like that, or uh, millions of the bits like that. Okay, so that we have to consider, and here we have to see the performance bottlenecks of that. So in that, the first point is the network monitoring. Utilize the network monitoring tools identify bandwidth intensive applications and services. Sufficient bandwidth is getting or not, or depending on the applications, how much the bandwidth is required. If it is not sufficient, that may create the error. Then networks segmentation. Segment the network to isolate heavy traffic and optimize the performance of critical applications. What is happening? We will say at the office time, the traffic is becoming heavy. Okay, so when the traffic is heavy, at that time we have to segment the network. We have to isolate in different parts, and we have to manage the traffic. Okay, so by that the performance of the system will get increases. Then network optimization. Implement the network optimization technique to reduce the congestion and improve the overall performance. Congestion is nothing but the heavy traffic by the number of customers are sending the packets on the same time, and that will increases the congestion. We'll say in simple way, we'll say it is the traffic jam, and by using some techniques, different techniques are there for this network optimization. Like that Bellman-Ford algorithm, on that, uh, like that we have to use for this network optimization. Then some security issues are there, security vulnerabilities that we have to focus here. So vulnerability scanning, conduct like regular vulnerability scan to identify the security weaknesses. If some security issues are there, we have to monitor that. Then next point, that is the patch management. Apply security patches promptly to address known vulnerabilities. Okay, so if we know the some problems, definitely we'll take care of that, and according to that, we'll do some prevention. Then next one is the firewall configuration. Strengthen the firewall rules to block unauthorized access and malicious traffic. If somebody is accessing the unauthorized users are there, or something wrong things, okay, that should be get filtered, that should get blocked. So the firewall configurations you have to do according to that. Then some troubleshooting strategies are there. So very first you have to identify the symptoms of that, then isolate the problem, test and verify that problem, and document the finding. Whatever the problems you got there, you have to document it, and you have to go for the fault finding according to that. Then next is the preventive maintenance practices. You have to adopt some preventive maintenance practices. Means that error will not occur and the fault will not occur in the computer network. So you have to do the regular monitoring of that. By that you will come to know the what is happening with the network. Then some software updates should be there. Regularly software updates. Nowadays the technology is changing fast, and you are going slow. That will not get matched with the current situation of the scenario. So you have to uh, go for the software updates. Then also you have to do the hardware inspection. Timely you have to, or we can say periodically, you have to go for the hardware inspection. By that, by observing that, you can see the some maintenance is required for that or not. So, key takeaways from this: by understanding the common network faults, implementing troubleshooting strategies, and adhering to preventive maintenance practices, network administrator can effectively diagnose and resolve the network issues, ensuring the uh, optimal network performance and uptime. Proactive monitoring, regular software updates, and hardware inspections are crucial for maintaining and stable and secure network infrastructures. So, like this, you can do the um, fault finding in that, or you can take the prevention in that. Okay, thank you. Hello, I am Professor Ramesh Khinde, working as assistant professor in Kekewa College of Engineering, and I am going to explain you some fault finding in computer network using network commands. So this presentation introduces the command network commands used for the troubleshooting and provides strategies to resolve the network issues. So one by one, I will show you these commands. So introduction to network commands. Some network commands are used in the fault finding. These are the types like command line interface, syntax, and then output. So under command line interface, network commands are executed in the command line interface, also known as the terminal or cell. Syntax, the commands typically have the specific syntax, including the command name and optional arguments, etc. And then output. Command displays the information about the network, its connections, or troubleshooting results. The first one is the ping command. It is used for the checking the connectivity. The purpose sends the test packet to the target host and measures the time it takes to receive the response. Then, if it is success, if response is received, it indicates that the target host is reachable. And if not, uh, means the failure is there. If no response is received, it indicates the connectivity issue or host is unavailability. So I can show you. I will show you this uh, in the command prompt. So we'll go for the command prompt. Here you can write the ping command and the enter and see, using ping command the packet is sent to the destination and uh, this is the analysis of that analysis of this ping command. For example, you can put the ping command and the destination like 192.168.1.2 destination, and then you enter this, then it will show the pinging, sending the commands. The reply from the destination is it is showing the unreachable. So I have just taken the mm, one destination host randomly. That's why it is not reachable. If you put the exactly the destination address, you will get the analysis of that. So here ping statistics for this 192.168.1.2 packet sends 4, received 4, lost 0. So here it has shown this correct result. Okay, sorry, correct result it has shown. Then next is the uh, trace route, tracing the network path. Trace route command, another command is the trace route command, tracing the network path. In that the hope is there, means the devices are connected one to one. Then time is there and troubleshooting. Third point is the troubleshooting. So under hope, each router or device in the path is considered as hope. The time it takes for the packet to travel to each hop is displayed, and the troubleshooting identify the potential bottlenecks, network congestion, or unreachable host. So again, I will show you here the under the command prompt. You can put this tracer command and enter this. As it is here, it is showing the tracer is not recognized as internal or external command. Again, 192.168.2.3, and okay, it is showing the uh, not, it is not for the internal, it is internal or external command, operable program or batch file. Here it is not recognized. Okay, I will show you it in another slide. The next one is the netstat, analyzing the network connection. Netstat is used for analyzing the network connection. The first part is connection, second is listening port, and third is the routing table. So connection display the active network connections, their status and associated IP addresses. Second, listening port shows the port that are listening for the incoming connections from other devices. And third is the routing table. This table provides the information about the network routes used for sending the data. The network table, it consists the all the routing information stored there for sending the purpose. Then next command is the ipconfig. Ipconfig configuring the network interfaces. Under that, the IP address is there, displays the assigned IP address of the network interface. Then default gateway is there, shows the IP address of the default router for outgoing traffic. As we know, the gateway is nothing but the software installed within the router. Okay. Then next is the DNS server, domain name server, indicates the IP address of the DNS server used for resolving the domain names to find the domain name. So this is the IP config, or it is used. It is used for the displaying the configuration of that. Again, I am showing you the with the command prompt here. You can write the IP config and it will show you the result of that IP configuration. Uh, Here, IP4 and IPv4 and IPv6 address it will show here. So here you can see this pinging command that is showing this IP configuration. Here it will give this statistics of that. You can see over here IPv6 address means used this is used for the IP configuration. Then next is the NS lookup. NS lookup is used for resolving the domain name. So for resolving the domain names, that is DNS. Enters the domain name such example .com. Okay. Then it sends the DNS query to the configured DNS server, and then IP address receives and display the corresponding IP addresses for the domain name. Okay. Then TCP dump, capturing the network traffic. This command is used for capturing the network traffic. Capture the filter. Specify criteria to filter packets based on the IP addresses, ports, or protocols. Then packet analysis, analyze the captured packets for the troubleshooting network issues, security analysis or performance monitoring. And the third part is the network monitoring. Monitor network traffic in real time for troubleshooting, security auditing or performance optimization. So this command is used for the capturing the network traffic, means will capture the packets. Okay, so this is all about the fault finding using some useful network commands. Whatever I have explained. Okay, thank you.